Science Week 2, Year 5. I hope you're all doing well and look forward to seeing you very soon. I hope you enjoyed last week. I got some really interesting feedback from you that you were wanting to learn about how to turn coal into energy, how do car batteries work. Are other countries ahead of us in terms of the development of renewable energy? I was so impressed by how fascinating your questions were. So well done on that. Today, what we're going to be looking at is something related. We are still looking at energy and forces. Today, we're actually looking at circuits. So we're going to have a look at that now. So our learning goal for today is that for you, students, you're learning to construct and test different arrangements of a circuit. So without any further ado, let's rip into that. What is a circuit? Now here I've got a picture of a simple circuit. We've got a battery, we've got a switch, we have a light bulb, very similar to the flashlight that we were having a look at last week. A complete and closed path around which a circulating electric current can flow. So it has to be closed, it has to be complete. If one of these wires was disconnected, our circuit would cease to work. Why is that? That's exactly the question that I've asked myself for a long time, and today we're going to find out. So a circuit is a closed path that electrons flow along to provide power to your home and electronics. A simple circuit contains a power source, a battery, or could be connected to, say, a turbine, like a wind turbine. It has wires and a resistor, a light bulb in our case. In a circuit, electrons flow from the battery through the wires and into the light bulb. And when the bulb receives enough of these electrons, it will light up. So the light actually comes from the electrons going through the little filament in our light. The filament's a little thin wire that you might see breaks sometimes when a light gets old, or if you have a surge of power, it might blow the filament in your light. When constructed properly, you'll be able to light your bulb with just a few simple steps. Now let's have a look and see what our circuit might look like. Will it look like this, I wonder? Now here we've got one wire going to one end of our bulb. I don't think it will, because we do not have a complete circuit like we did here, where the wire is in contact with both sides of our battery and forms a complete circuit for the electrons to flow around. In this case, we just have the electrons flowing from the battery and stopping. So no, the electrons won't be able to pass through the filament and back into the battery and continue on their journey around and around, because it is only going one way. This idea is called the push idea, where people sometimes at the beginning of electronics being something that was investigated many years ago, they thought that electricity could be pushed out of the light and shone out as light, but it does not work that way. This is a different idea, where people once thought as well that electrons clash together in the middle of this circuit, and that's how the light was formed. But that's not how it works either. We need to have a continuous flow. So you can see here the electrons, this diagram showing the electrons coming out of one side of the battery as well as the other and meeting in the middle. That's not how circuits work either. Now this one is a common one, and it's kind of how circuits work. People think that electrons come out of one way, fully charged, they go into the light, they lose some of their charge, and then they go back into the battery. That's not necessarily true either. The number of electrons actually, some people believe that lots of electrons come out one side, lots of electrons, they go into the light, and we lose some electrons, and only a few make it through back into the battery. But that's not true either. The electrons actually never decrease in number in this circuit. What happens though is that the chemical energy that's stored in this battery over time, it stops being as strong. So we lose our chemical energy. All right, we might come back to this, but what we're going to look at first is a complete circuit. Now here we've got a weird looking diagram. We're going to talk about that more in weeks to come. But over here we've got something that's a little bit more recognizable. We have our light bulb, which you should all know. We have blue lines representing the wire, and we have our battery. Now you'll notice that the wire goes from the light bulb into the positive side of our battery, and then it goes out of the negative side of our battery and into the other side of the light bulb through a switch. Now over on our diagram here, we have the same exact thing. We have our battery, we have our switch, which is signified by this block of wire that can either be connected or disconnected. In this case, it's disconnected. And we have this symbol to represent our globe. All right. So this leads me onto our first activity. We've learned a little bit about how circuits work and about how electricity and electrons pass through our circuit. What I want you to do is pause this video now and to go to your iLearn page. So you can see here I'm on Mrs. Adams iLearn page, and I'm going down to term 2, week 2, how circuits work. And from here, I can see today's activity and this activity 1. So can you all pause the video, go to this link now, and it will bring you to this game here. And what this game is a way for you to experiment with different circuits and different batteries, etc., and see whether or not you can get the circuits to work. You can press this button here to change the type of battery you have. You might put a 3-volt battery over there and turn it on and see if that changes the outcome of your circuit. Let's see if that changes. Yeah, there you go. More voltage equals a brighter globe. And you can also experiment with things like coiled wire and see how that affects your circuit, as well as putting extra light globes in. So have a look at the instructions at the top and see if you can follow them to finish each of these activities. All right. Hopefully you had a go at all of the activities on that website and you're ready for our next part of our lesson. The next part is to go back to your iLearn page and to explore these 3 websites that I've put there for you. They have different links to different circuit building activities like Circuit World here, where you can connect your battery and these lamps and light globes and resistors, motors, amp meters, buzzers, etc. And you can have a look at it either in a diagram form, a cartoon character form, or a component form would be a better name for it. There is also this one where you can build some different circuits like this and see if you can get them to work. You can click there and double click to separate those as well. And then you can use your switch here to turn your circuit on, etc. You need to obviously connect everything with wires. And then finally, there is this website here that has a number of different games that you can use to have a look and see how your circuit knowledge is and whether or not you can build some fun circuits. After that, you can see here I've written, I look forward to hearing how you went next week in class, because next week, if we are back at school, we will actually be able to begin experimenting with real circuits, with real batteries, and seeing whether or not our knowledge of how circuits work is developed enough to make some new circuits of our own. The final thing that you need to do today is to make sure you tick the box on the iLearn page to confirm that you have completed the lesson. You can't really see it on my screen unless I move this over, but just here you can see there's a little box there that I can click, and that will tell me that you have watched this video and that you have completed your iLearn task today. All right, thank you so much, Year 5. I hope you have a really great weekend, and I look forward to seeing you next week at school.